Welcome back to another lesson with Mr. Chen. Today we will focus on the topic types of soil particles. Alright, so we are going to look at the types of soil particles. However, before I get into the lesson, I want to introduce to you the La Pearl Nursing Home, which is located in Fraserwood Drive, Highgate PO, St. Mary. And if you need the best health care with family values for your loved ones, then you can go over and check that nursing home out. I'll leave the contact information in the description below. The objectives of the lesson are: number 1, to identify the 3 main types of soil particles. Number 2, to differentiate among sand, silt, and clay particles. Number 3, to define loam and list the types of loam. Number 4, importance of soil particles. And number 5, to demonstrate how to test and interpret soil samples using the sedimentation method. Alright, so let's delve into the lesson. Alright, the first objective: what are the 3 main types of soil particles? The 3 main types of soil particles that are important to agriculture are: number 1, sand; number 2, silt; number 3, clay. And please note brief that loam is not an individual soil particle. Loam is a mixture of soil particles. So that note brief is very important. Alright, so if you noticed, we only list 3 soil particles here, and it is because those soil particles are mostly important to agriculture. Of course, those are the 3 that we will be focusing on. Alright, so we have some key points. Alright, key point number 1: sand, silt, and clay are inorganic components of the soil. Very important. Number 2, sand, silt, and clay are derived from rocks. Very important. Number 3, a mixture of sand and clay alone or all 3 particles is referred to as a loam. Very important. So we are also going to look at the types of loam. So when we reach there, we'll get into detail. Alright, as I said, the sand, silt, and clay particles, they are examples of the inorganic component of the soil. Of course, from the diagram, as you can see, stone, gravel are also a part of the inorganic component of the soil. However, they are not considered to be the regular soil particles that are important to agriculture. Alright, and that is why we have gravel as a soilless media, and even stone could be referred to as a soilless media as well. Let's move on. Of course, sand, silt, and clay, they are derived from rocks. Now, let us go through quickly the types of rocks that these particles are derived from. Alright, so sand is derived from sandstone, silt from mudstone, clay from shale. Alright, that is just to whet your appetite. Alright, so let's get into the characteristics of the 3 soil particles here: sand, silt, and clay. Alright, so as you can see, these are real pictures of the particles. So we have sand here, silt, and clay. Alright, so let's start with number 1. Number 1 for sand. Let's start with sand. Number 1, they are large in size. So comparing the 3 of them, that's what we are basically going to do. We're not talking about gravel or stone, just the 3 of them. We're comparing the 3 of them basically. So as you can see, the sand, it is larger than the other 2 particles, larger than silt and clay. Number 2, it has large space in between them. Because the particles are large, they will have large space between the particles. Alright, number 3, the sand particles, they will feel gritty, rough, or coarse. Alright, number 4, they are non-sticky. So of course, gravel will feel non-sticky. They are non-sticky in nature. And if you ever feel any stickiness on them, it's because of the water that is on them or other particles that might be on it. Alright, number 5, they have good drainage ability. You see, because the particles have a large space between them and they are non-sticky, they provide good drainage of water. Number 6, they have poor water holding capacity. So the opposite of drainage is the holding capacity of the soil. So sand will not hold water. All right. So let's get to silt. Silt is medium in size, and what that will result in is that they are medium in space. The space between the particles are medium as well. Number 3, they are smooth and slippery and flourish. Number 4, they are non-sticky. So similar to the sand, they are non-sticky. Number 5, they have medium drainage ability, and number 6, they have medium water holding capacity. All right, so let's go to clay. Now clay is very unique when compared to the 3 particles. So number 1, they are very fine in size, and what that means is also number 2, the space between the particles will be very close as well. All right, number 3, they are sticky when wet, very important. Number 4, they are hard when dry, and what that means now, number 5, is that it has that ability to swell and shrink, and that is because it can absorb water. So it will get larger when it's wet, and it will shrink when it's dry. So in the summer times, when you see your soil crack, it is because of the clay particles that are present in the soil. All right, so let's go to number 6. Number 6, it absorbs water. Number 7, poor drainage. And number 8, good water holding capacity. So out of the 3 of them, it has good water holding capacity. However, the bad thing about it is that it has poor drainage. That is the characteristics of the particles. Now, if you are going to draw these particles, if you are required to do a question on the particles to demonstrate using drawing and labeling of diagram, then this is a way you will present your information. So for the sun, you'll make sure that the shape of the particles, when compared to the 3 of them, show that they are gritty. So as you can see, with when you compare the 3 of them here, if you look at all 3, you see that the sun, they are irregular in shape, they have grit on it, so that will reflect that it is coarse. It will have a coarse feel. So the sand, it should look larger than silt and clay. It should look irregular in shape. It should have grits on them. So when you draw them, it should reflect all of that characteristics, and also it should have the larger space in between the particles. So you have to show that in the diagram. So let's move to silt. Silt is medium in size. They are more round. That would reflect that flowery feel, right? And the space in between them should be medium. So that's basically it for that. The clay should look the smallest. The clay is the smallest of them. So when you draw your diagrams, the clay should be looking very small. The space in them would be closer than the other 2. So those are the 2 distinct characteristics when you're drawing the particles. And of course, they are not irregular, more round in shape to give a smooth feel. This diagram here is the best way of presenting the information if you get a question to do in a test or exam. And of course, you can just list the 3 main distinctive features for each. Alright, so let's move on. So in order to measure their millimeter, you use a sieve to do that. Alright, so out of the 3, sand would be larger. It is 2 to 0.2 millimeter in diameter. The silt is 0.02 to 0.002 millimeter in diameter, and clay is less than 0.002 millimeter in diameter. Alright, so very importantly is your loam soil. So let us get a bit in detail with our loam soil. So as we said now from the definition here, it said that loam is a mixture of the other soil particles, mainly sand and clay. So loam is a mixture of soil particles, right? It doesn't mean that it has to be just sand or clay. Alright, it could be sand and silt, or a mixture of just silt and clay. But for this lesson, what you're required to learn is the mixture of sand and clay. So that is what we're going to focus on this slide. So note brief, there are other types of loams that exist. So not only these 3 that are listed on this slide, but there are actually other types of loam that exist. But we are going to look at these 3. So let's go into it. There are 3 main types of loam. Number 1, we have sandy loam, number 2 medium loam, and number 3 clay loam. And the definition for those and name of those, they are determined by just a mixture of sand and clay alone. All right. The sand loam, it has more sand in it than clay. So this sample of soil or this loam, it will have more sand particle in it than clay particles. And the medium loam, it has equal amount of sand to clay. And number 3, clay loam has more clay in it than sand. Very important. All right, let's get to the note brief. This loam is based on a mixture of sand and clay only. Very important. All right, so there you have it for the loam soils. Now, I'm going to show you 2 other examples of loams. So, example of other loam soils. So, number 1, we have silt loam, right? So, with the silt loam, that loam will have more silt in it than clay. So, in this case, we are looking at just silt, a mixture of silt and clay. If you say silt loam, it means it have more silt in it than clay. And number 2, we have silty clay, which would mean equal amount of silt to clay. All right, so there are other types of clay. Of course, you could say sand silt or silt sand or silty sand or silty loam when you're comparing just sand and silt. All right, so that's basically it for the loam. I hope you understand that part of it. All right, so let us get into another subheading, water holding capacity. So that is a very important topic. So when you're dealing with the soil in regards to the particles would basically affect the water holding capacity of the soil. All right, so let us go into the definition of what a water holding capacity is. Water holding capacity is the ability of the soil to hold water over a period of time. All right, very clear and simple. Note brief, the water holding capacity of a soil depends on the particle size of that soil. Very important. All right, water holding capacity. Each soil particles have different particle size and therefore has different water holding capacity. All right, so the water holding capacity for sand is different from that of silt and clay. That's what it's basically saying. And it is because the particle, their size, the size of the sand, silt, and clay, they are different. That is why. All right, so here we have a diagram showing an experiment that was done on the water holding capacity of sand, silt, and clay soils. All right, so here, let's read the important notes before we get into it. So 1 cup of water poured into each container of soil. So this is the container with the soil, this gray here, this represents the soil. Alright, now the same amount of water, when you're doing this experiment to test the water holding capacity, you want to use the same amount of water in each sample of soil. So for the clay, 1 cup of water was poured on the clay soil, 1 cup of water was poured on the silt, and 1 cup of water was poured on the sand. Now what happened is that this experiment was observed after 25 minutes. So you're going to pour in the water on the soil and make your observation after 25 minutes to see the water holding capacity. Alright, so let's read some more. Which soil particle has the best? 1, water holding capacity, and 2, drainage ability. Alright, so we're going to answer those based on this diagram that is present. What you need to know is that the water holding capacity, it is opposite of the drainage ability. The blue color here represents the water. Let us make our observation. Water holding capacity. Which one shows that it has the best water holding capacity? Alright, so the water was poured from the top. Let's look at the sun. The water drains from all the way from the top to the bottom. Some of the water was seen in the bottom of the container here. With silt, the water drains only to half the container of soil, and clay, just a small amount of water moves down. So which one would have the better water holding capacity? Alright, so the answer would be clay. Alright, number 2, drainage ability. Which one will drain water the fastest? And the opposite would go to the sand. So the sand will drain it and the clay would hold more water. Silt is in between. I remember a question asked by some students: is silt the better soil particle? Well, the answer is really no. Even though it drains medium amount of water and hold medium, it is not the best because it is still non-sticky. It will not hold nutrients as much as clay. Alright, so out of the three, no one alone is the best. So that's the best answer. If you want a more balanced soil, then it's best to use a mixture, which is the loam. So for most crops, they do better in loam. If you're going to plant like rice and you need a swamp, then you use clay. So based on the type of crops you're going to plant, that's how you determine the better soil. Alright, so let's move on. So here is another diagram showing you how to test a soil to find out the different particles that it has, or the proportion of particles that it has. So you could carry out the sedimentation soil test, which is a simple test. All you need is just a container with some water, and you pour the soil in the water. You take up the soil that you want to test and you place it in the water, shake it up, and leave it for a day to settle, and then make your observations. This diagram here, let us analyze sample A. So when the soil was placed in this container, this is the amount of sand that was seen, and this brown area here represents the amount of silt, and of course the water is clear. So what that is saying is that this soil, it has more sand in it than silt. So this sample of soil that was tested here in this diagram, it was a sand silt loam, or sandy loam. So it has more sand in it than silt. Alright, so let us analyze sample B. So when this sample of soil was added to this water, you can see that here some sand particles were observed here, and here in the water we have particles suspended in the water, which will represent the clay. So basically this soil sample has clay in it and sand. It is basically a medium loam. It doesn't have anything floating on the top of the water, so it doesn't have any organic matter in it. Alright, so let's look at sample C, another sample. Alright, so sample C here shows materials floating in the water. If there are materials that float on the water, it means that that soil sample has organic matter in it. The water is clear, so it means no clay is in the soil. And then we have silt and we have sand. So it has a larger portion of sand in it than silt, and it has some organic matter. Alright, so it is a loam soil. Alright, when you're doing the sedimentation method, there are some key points that you should look out for that will help you to read or analyze your experiment. So those key points are: number one, the larger particles will sink to the bottom. In the water with container, the sand will be at the extreme bottom. Silt will be on top of it. If there is no sand in the sample, the silt will settle at the bottom. Alright, so the larger particles will settle at the bottom. Alright, number two, clay particles will suspend in the water. Alright, number three, organic matter will float. So if there is any organic matter that is present in the soil sample, it will float on the water. We are now to the importance of soil particles. Why are these particles considered to be important? Why is it important that we test our soil to identify the different soil particles? Alright, so we are going to get into that. We have 2 points on the slide. So let us look at the note brief before we go into them. Note brief: a fertile soil will have enough water and air in it, not too little or too much. So when a soil is described as fertile, it means it has equal amount of water. It has everything that the plant would need. Alright, there's no shortage of any of the components. There's not any shortage of water, nutrients, air, etc. It should be balanced. Let's look at importance number one. If the soil is draining water too easily, clay can be added to it. Clay absorbs water and slows drainage. Alright, when you test your soil, you realize that it has a lot of sand, then possibly it will drain water too easily. Meaning, if you add fertilizer, what will happen? Chances are that your fertilizer will be leached out or washed out of that soil easily. So that is not good. The plants will be dehydrated easily as well. Alright, so what you need to do is to add some clay to that soil. Alright, very important. So you can make adjustments. So when you carry out these tests and you know your particle buildup of your soil, then you can make adjustments to your soil. All right, you can save money by carrying out these experiments and by knowing your soil makeup. All right, number two, if the soil is holding too much water, and that is described as waterlogging, sand can be added to it to improve drainage. Right? You don't want too much water in your soil, because what that will do is to rot the roots of your plants. It will promote the growth of fungus, commonly called root rot. So the roots of your plant will rot if too much water is present. So you can add some sand or silt to improve drainage to that soil. Alright, so the overall main importance of learning about these soil particles is so that you can know your soil buildup and know how and what type of adjustments to make. Alright, so we are finished with the lecture side, or the content side of the lesson. We are going to go into the practical demonstration. Welcome back to the channel with Mr. Chen. Today I'll do a practical demonstration of how the sedimentation soil test method is done. Now, it is a very simple and easy method to use. If you have a farm and you want to know the particles that make up the soil on that farm, then you can go ahead and practice this soil test method. Alright, so let's get straight into it. Alright guys, so the materials, tools and equipment that we will be using are your bottle, or a simple glass container can use, where you would put your soil in. Of course you need soil, so I'm going to go and get some soil shortly, and that soil would be from the area from which you're going to do your soil test. So any area of the soil from where you're going to do the soil test, that's the area that you're going to take the soil from. Alright? Alright, the next thing you need is water. Okay? You might need cloth for cleaning your hands, etc. And you need a tool to assist you in taking up the soil. Now this tool is used basically when you're doing putty, to spread the putty. Alright, but I'm using it now to take up the soil. Alright, so let's start with number one procedure. The number one procedure is that I'll gather all the tools and materials that I need. Now, number two is I'm going to pour some of the water in the container that I'll do the sedimentation test. And I 3/4 fill the bottle with water. The next step is I'm going to go and get the soil. So I'm going to select the soil over there from that plot. So alright guys, so this should be good enough. So the next step now is to place the soil into the container of water. Alright, so remove the cover. I make the soil in smaller pieces so that they can go into the water. I prefer to put 1/3 soil compared to the water that I have. So this is the amount of soil I had. I divide it into 3. I divide it into 3. 1, 2, 3. So I want to put soil up to here. Alright? So when you're doing this, guys, it is best to do this test from more than one area of your land. So if you're doing farming, you try to take soil from more than one area and note those areas. Record the observation, because you might have different soil particles on different part of your land. So it is good to do it from a number of areas of your land to get a consistent reading or accurate reading. Now guys, I think I've reached the 1/3 mark here with the soil. So what I'll do next is to cover the bottle, and then I'm going to shake it vigorously. I want to break all the particles. I want all the particles in the sample to be separated out. Alright, so I shake rapidly. Alright guys, so what I'll do is to wait 1 day. So I'll put this down 1 day to settle out, for all the particles to settle out. Yesterday I already done this experiment, so I'm going to show you from that experiment that settled, and then what we'll do is to identify the particles. Alright, so let me get that experiment that I have done. Alright, so I'll try my best not to disturb the soil particles. Alright, so this is when it is done. If you notice, the particles are not yet settled out. Alright. Alright, so let's go straight into it and see the particles that are present in this sample, and also the proportion or percentage of particles that are present. Alright, so let's start with the particles from the lower end here. The larger particles normally sink to the bottom. You come around this side. Right? So here, from here to here, you can see that we have larger particles. So we have sand particles from here to here. Now from here to here, you can see that the particles are very fine. So these are your silt particles. They are very fine, they're looking very smooth. Alright, so it's about equal amount of sand to silt here. Now in the water here, the water is cloudy with particles. Now those particles would be your clay particles. So clay particles are normally suspended in your solution. In the water, they are normally suspended in the water. Alright, so if you notice, the water is dark brown, is brown. Those are your clay particles. On top of the water, the organic matter floats. The soil that we have over there, what it is showing us, it is that it is a loam soil. It has equal amount of sand to silt, and it has clay in it. Alright, so it is more like a sand, silty clay loam, a medium loam. Alright, and it has organic matter. Now, if on the other hand, there weren't any particles suspended in the water. Say for example, the water was very clean and the particles were separated down here. It would mean that the soil does not have any clay in it. Alright, so you might, if you're doing your experiment, you might find sometimes that your water is very clear. It means that no soil, no clay particles are present in that soil. It would be maybe silt or sand, depending on what the proportion would be. Alright guys, so the next step now is basically to clean up the area. So guys, thanks for watching. I'll try my best to provide you with as much educational videos, theory, practical as possible. Remember to subscribe. That is how you will get your automatic update when I release a video. Please leave a comment in the comment section. You can make requests of videos that you would like to see. I'll try my best to present them. Until next time, thank you. Thanks for watching.